You're starting.
I'll start, I guess.
Hey guys.
Here we are again.
Yep.
7.5 trigonomic ratios.
This is a good one.
The T word.
Yeah, but this is fun, guys.
Yeah, this is fun. I really like trigonometry. It's pretty fun.
Yeah.
So I mean, hey, more right triangles, guys, and just some new ideas to present to you here. And I mean, it's going to take you a little bit to get used to, but I mean, it's really not a hard thing to get used to. It's just a matter of, do you understand ratios? And you should, since we did them in Chapter 6.
Right.
Have an idea what a ratio is, and now it's just about applying some different ideas to it. So if you don't have your scientific calculator, though, you're in trouble.
Yeah.
So plain and simple, get it.
Have to have it.
Yeah. Anyway, so trigonomic ratios are the ratios of the lengths of two sides of a right triangle. Okay, so that's what we're looking at with trigonometry is the ratios of the lengths of two sides of a right triangle. So the three ratios we will use are sine, cosine, and tangent. Now it's not sin. Everybody always wants to call it sin because you see it on your calculator with no E on
abbreviated.
it. Yeah, and so it's sine, guys. Sine, cosine, and tangent. All right. And look, this is a really good little formula we have, kind of like PEMDAS, where it's please excuse my dear Aunt Sally for parentheses, exponents, multiplication, yada, yada, yada. We're going to use this idea of SOHCAHTOA to help you guys kind of remind, or help yourself remember, when to use what. And I don't want to go too much into what it stands for yet until we see the other parts. So let's just go. But
notice the S, the C, and the T. That's sine, cosine, and tangent, and then we'll look at the rest of it from there.
Exactly. So when you see those words, you know that you're going to need those other parts coming after it, and we'll talk about that here more.
Right.
So go ahead, Mr. Scritchfield.
So again, we just want to make sure you understand that what we've already covered so far, Pythagorean's theorem, that only works in right triangles, only, and trig ratios only work in right triangles.
Yay.
So that's all we're focusing on, okay? And so we need to remember the pieces of a right triangle. And so we're labeling complementary angles inside of a right triangle here, okay? And so if we're looking at that yellow angle down there, angle L, okay, we want to know what side is opposite of that angle. Well, as that angle opens up, as the yellow is showing there, as it opens up to side JK, JK is the side that's opposite that angle. Okay? H is always the hypotenuse, always opposite the 90 degree. It's always the longest side of the triangle. Okay, so H is hypotenuse. And what does adjacent mean from back when we were talking about adjacent angles and so on? Adjacent means right next to. And so adjacent is the side that is right next to the angle. In fact, the side makes up part of the angle. And so angle L, the side right next to it is KL, the bottom of the triangle. So you have to understand that. I mean, that's what all of this is based on.
Right.
You got to know which side's opposite, which side is adjacent, and then the hypotenuse being the hypotenuse. You have to know that because that's what that whole SOHCAHTOA thing is about. And that's what all the trig ratios are based on.
I always try to tell my kids at least get good at finding 2 out of the 3. And then you can always know that, then the other one's got to be this one. So, I mean, the hypotenuse is pretty much the easiest one to find, guys, because there's going to be a right angle in there. So the corner of the box points to the hypotenuse on the other side. So that's an easy one to find. And just get good at either finding the opposite or the adjacent, and then you know that the other one is the one you're not as comfortable with.
Right.
And, but this is the key. If you can't find O, H, and A, well, you're dead in the water. So
you have to understand this concept.
Yeah, figure this out.
Yeah. Okay, so O is the opposite side from angle L. We're looking at angle L, and it does matter. It's critical to what angle you're talking about. Right now we're talking about angle L in the triangle. And so O is opposite of that. H is the hypotenuse of this triangle, okay? And A is the adjacent side. And so those 3 pieces you have to understand compared to angle L, because they change if we were talking about angle J. They're different. And so that's what we're going to see here. Now we're looking at the pink angle, angle J. Those things change. Now the hypotenuse never changes. That's why you were saying that's the easiest one.
Right.
The hypotenuse always stays the same. It's always the side opposite the 90. Now the opposite side from angle J is KL. Okay, and the hypotenuse is hypotenuse. The adjacent side is now the one that is right next to that pink angle, which is JK. So it's all relative to what angle you're talking about. And we never use the 90. We don't talk about the 90 because then the opposite would be the hypotenuse and you'd be stuck. You'd be without a side. It's always the 2 adjacent, acute angles in the right triangle that we're comparing.
Okay. And if you're struggling with this, guys, I highly recommend just go back rewind this part and watch it again, because seriously, if you can't get this, you're going to be in serious trouble with it. The rest is easy.
Yeah.
It's just a matter of plugging things in, really.
Yeah, you'd be lost the rest of the chapter without this.
Yeah.
So, okay.
All right, so SOHCAHTOA is how we set up the equation. We saw that on the first slide, and so basically, here's what it is. The sine, which is the S in the SO, sine of angle X is equal to the opposite side over the hypotenuse. The cosine of angle X is the adjacent over the hypotenuse, and the tangent of angle X is the opposite over the adjacent. And if you look up there at the top where it says SOHCAHTOA there in the purple, you see that S is for sine, O is for opposite, and H is for hypotenuse. And you can kind of see the ratio there. And then cosine X is, angle adjacent over hypotenuse, and tan X is TOA, and that's opposite over adjacent. And there are 4 parts to this. The trig times the angle equals the OHA ratio, and you just got to learn how to find the right ratio, guys. And then this is pretty much easy. So the trig function next to the angle that you're looking at equals some form of the OHA ratio, and then this is pretty simple to do. You're just setting it up based on what you know, and then doing some basic algebra and working backwards. I mean, it's pretty straightforward.
In terms of understanding it, you just need to make sure that you understand that these are just 3 ratios. We could call them Bill, Joe, and Bob. They could be named anything. They just happen to be called sine, cosine, and tangent. That's the name of them. And they are just specific sides, 2 sides of a triangle, right triangle, that are in ratios. And we just have these names for them. Okay? But you do need to understand that the sine, cosine, and tangent, the trig ratio there, is an operation. It is like putting a radical over something or whatever, a plus, minus, multiplication, division. It's an operation happening to that angle. Okay, it's not a separate thing that you can just get rid of somehow.